Hi friends, welcome to my YouTube channel again today where I share ideas. I've got another great idea to share today. I do a lot of lathe work, and it's easy to make bowls, etc., because you just have a handheld gouge or tool, and you can do the insides and the outsides quite nicely like that. But then I want to step it up a little bit and actually do the inside and make hollow turnings, what they call hollow turnings. And that takes a device to hold your tool bit or gouge as you enter the inside of a project. And if you really want to get fancy, you do a very small hole at the top and then you hollow it out. There's a number of devices on the market to do that. I built one a year or so back, and it used 2 rollers and a square bar, and that stopped it from twisting. It worked quite well, but I wanted to step that up a little bit and do another project. Another type is what they call kind of a D handle, where you have a slot and the tool that you're using has another section on it, and it rides in the slot also and stops it from turning. But the ultimate, I think, is what they call an articulated arm. There's a number of different kinds out there that you can research, and but they're quite expensive, and I'm just doing this as a hobby, so it'd be nice to have one, but you know, you don't want to spend $300 or $400. So today I'm going to show you one that can be made for less than $20 in Canada even. So, and it's been using it just a little bit. This is just the prototype, so I can get the kinks out of it, but there's a number of people who want to see it, so I'm going to introduce it to you today. So I wanted to build one that was cheap and it would work well, that anybody could do at a low cost. So the ones you buy are out of steel, but the major components of this one is out of wood. So we'll just take a look at it here so you can see what an articulated arm does. It's the one requirement for inside turning is some sort of a boring bar that you can go inside and work in there. And with the articulated arm, it's got joints on it here, so it works like an arm, and you can move it anywhere you want and to do the job that you want. And pull it out and go in. And so far this has worked really well. Now on this one here, it's built a little bigger and a little heavier duty than probably my next one. But you take a piece of wood like this compared to steel, and there's no way that you could possibly twist that or bend it. Yeah, you make it smaller with steel, and these arms can be smaller out of steel, but it makes it a little more difficult to hold. I've chosen for this particular one, I'm going to do some other models where it attaches right to the tailstock. So that means you have a lathe, you have a tailstock, you can make a clamp, this clamping assembly here will just go right on there, and you just have a few components. Now inside here, there's a ball bearing ball bearing that goes inside of this piece of wood here. That's why these have to be a little thicker, and it's bored in with a Forester bit. Then the bearing is pressed in, and with some washer underneath here for a spacer, washer on top to spread the force out to the outside of the bearing. It works well. There's no give in this unit here. And then I've added here another component in there. Right now it's with screws. It's not glued because I'm not sure exactly how to make that, but it seems to have it in the right position there. The little bit that I've used it, I'm very happy with it. But with wood, there's going to be shrinkage or expansion. So you have to, I found that today, well, this wood was not kiln dried. If I was going to make the next one, I'll use kiln dried oak or something like that. Make it a little fancier. You don't need a lot of wood for it. It just needed tightened up a little bit. So the wrench, bang, tightened up. So all you need is 2, 4, 6 bearings and 3 bolts and a couple other little bolts here. And that's all you have to get. It's a very common bearing I'm using in here. It's a 6102. There's a Forester bit that just matches the outside, and then you have to buy a metric bolt because it's 12 millimeter on the inside there. So anyway, again, I just salvaged stuff out, and this was a shaft that was laying around from something. You can see the spline here, and I got it. This was my first one that I made. I've got some other ones that I'll show you, but I had a unique idea here, and but I don't think it's a little simpler way to make. The ones I made next were even more simple. This one here, there was a socket, a 3/8 drive socket that was welded in here, and then an extra piece of metal put on the outside. So the idea was you just loosen it and pop it out. You pop a new one in, but it's locked in place. There's no way you could turn it because this is a extension fitting into the socket there. Anyway, and so we're just going to turn on, and I'll just make a couple cuts in here while we've got it going, and then I'm going to put on a bowl where you can actually see it working and cutting a little bit better here. So anyway, I'll just get this going here. I found that if I put that in there, I could pull it out. So you can see I've been lathing on here quite a bit here. This is the first time I tried it on the holding it from the outside, but I kind of like it. I got a piece of tape on here which tells me when I'm near the bottom there. Starting at the bottom. And once that, we take that out, now we have to blow the inside out. And the centrifugal force holds the chips around the outside, and it actually plugs up so much that you can't lathe it. So turn it off, and I've got this air nozzle with a long tube on it. Really works good so you get the air back in there. So I was just doing a little bit there, but you can see that it actually took off quite a bit from there. Okay, well, I've got this on the lathe. I'm going to put another boring bar in here and show you. This one won't get inside and all the way around here. You have to use a little different type here. So I'm going to take this one out, put a different boring bar, and we'll just do a little bit more work. I have a video here fairly shortly about boring bars and the different types of the material that I use here. But I found that you don't need to lock it into something like that other one. You can put set screws in here. I sent somebody to town for set screws. They brought cap screws back, but so I've got to get set screws. And so this is this end of this one here. I made these little parts here, as you can see there, and that can be pivoted around so you can get right around the outside. And with this articulated arm here, you can go all sorts of different. You can get right in behind, and anyway, to get this in, I have to go that direction. These could be made a lot smaller and work actually a lot better. So I'm going to go in this way and then get it right in, and I'll move it back here, and I'll start lathing in this section of the bowl here. There's quite a bit of wood there, so I won't have to worry about it for now. But anyway, let's get started here. And well, we'll see what we got inside of here. Okay, pop that out of there. Okay, it's probably getting quite big in there. Anyway, what I haven't done, because I'm just showing this here, is you need to, the first one I worked on here, unfortunately, I cut right through up in here, and but this was a laser assembly that I used for my other, the other first boring bar that I made, so it could be attached to here, it could be a piece glued on here with a, so I just have to make a laser attachment. The idea of the laser is you adjust your laser so you're just off the point of your lathe bit, and you can tell how thickness is. So when that's on the thing, you've got it thicker, and it just as it comes to the outside edge and drops off, you know you got to that thickness. But right now I'm just showing you this new articulated arm that I made, and we'll work on some of these refinements after. I can see that this assembly here, this could be made a lot smaller to get into even smaller holes, but it's going pretty good in there. Anyway, we'll it works. Can't complain if it works, you know. But you could, for 20 bucks or 15, does a good job. Anyway, I'll put a bowl on here, and then you can see the tool working inside the bowl. Okay, so I'll take this off. On that video, you probably noticed vibration, etc., and it would have ran a lot smoother if I would have put a steadied it with this device here. And the first one I was working on here earlier today that I cut through, I had this on here, but on this one I put extra screws in back here, and I thought it'd be nice just to see the whole thing and not have the steady rest interfering with it. But if you do that sort of thing, it'd be, especially on a large one like this, it'd be good to use some sort of steady rest. Okay, I'm going to just demonstrate this using this bowl. This is a bowl that had dried and it was all out of center. First time I tried it, I used this this bowl here, and so you can see how it can move around from one side to the next and get into the different places there. So we'll just make a few cuts here, and now move over here and go from the outside in. Anyway, just showing you that how the articulated arm works, and you got complete motion just as if you were doing it holding the chisel by hand. Of course, building a bowl, I don't recommend you using this unless it's quite a deep bowl, but it could be the gouge will do a much smoother, better job than this. But anyway, that's how the thing works, and so far I'm quite happy. So I'll be making another design so you don't have to attach it to the tail stalk, and have some more upgrades for this. I'll be probably doing one just with the boring bars, a short one on the boring bars, what my experience doing that, so you can make them quite cheaply. Anyway, thanks for watching, and yeah, if you subscribe, you'll get a lot of new ideas this winter. So, we'll see you next time.